Good morning. Today is Monday, April 6th. This is the first day of the second week of our online presentations. We are going to be covering skills D9 and D10. D9 it will be covering linear functions over what we call unit intervals, and also we're going to look at the slope of any function using the notion of average rate of change. I want to also remind you that our goal is a score of 85. You want to get to 85 points to achieve mastery. If you want to go over that, that is fine. Now, just so you are aware, tomorrow evening, that is, on the 7th, the district board will be meeting, and at that time they are supposed to be going over grading policy. So hopefully on Wednesday we will know the answer to that. And as a result, we're still kind of in this mode of wait and see. And so I'm going to tell you, keep working on these. These are review items, but these particular areas, again, are important to understanding how we come up with the concept of slope in higher level functions. Okay, so let's move on. Do not forget that you should be writing down everything that you do. Use the plastic sleeve with whatever sheet of paper you've got in it. I have graph paper here, and I also I'm perfectly fine with using blank paper for much of what I do. But as you will see today, we're looking at a couple of graphs. The skills do not ask you to actually look at graphs necessarily in all cases, but if you can visualize with a graph and sketch one, it might be a good idea to use the graph paper with a plastic sheet, and it just makes it easier to sketch your graph. Okay. So let's look at the first example. You're going to be finding the slope of the equation of a line over the unit intervals given, and in this first example, the unit intervals are x equals 3 and x equals 4. So g of x, of course, is your output, and you're going to have an output for each of these inputs. So these are your inputs. Okay, and so in looking at this, if you look at this graph and you want to find the slope, and of course remember this is slope we're talking about up here, you could easily go over here to where x is 1 and go up to the line, and you'll find going over to the left that your y is also 1. So x is 1 and y is 1. So we could easily see from looking at this that y equals x. So this is the equation of y equals x. And I'm just going to put that up there at the top so that you can see that. You know, of course, this is your x-axis and this is your y-axis. All right, so we want to go ahead and determine the intervals. And let's think about what it is we're doing here. So let's look at the x's. X here is supposed to be 3, and that's the first x we're going to show, and the second x is 4. So I'm going to go over here to where 3 is on the x-axis, and I'm going to put in a 3, and that's going to be my first x, so I'm going to call it x1. And then I'm going to go over to where x is 4. Oops, I put it in the wrong spot. Let's get rid of it there. X is 3 over here. All right, and so this is your x1, and then where x is 4, that's right here, I'm going to make that my x2. All right, and so when we go up here to where x is, the x3 touches the line, and then go over to the left, you'll find again that your y is 3. This is going to be your y1. So your x1 has a y1 that corresponds to it. And then with x2, again, dashed line up to the line, and then you're going over with a dashed line, and you find it 4, where y is 4, that's your y2. Okay? So you can see here that there basically is an interval between each of the y's and each of the x's of 1. Okay? So let's just look at the math of that. All right? So what we're saying here is, as the input x increases, put a little a in there, increases from 3 to 4, the output, and we're going to put this into function form, the output is going to be g of x increases by 1. Now again, we can sort of deduce that just by seeing that the difference between the x1 and the x2 is 1 unit, and the difference between the y1 and the y2 is 1 unit, and 1 over 1 is 1. But let's put that into the math. So we're going to do the change in y over the change in x. And remember that this triangle means change in. So that's also the same, of course, down here, change in. All right, and that equals your y2 minus your y1, that's the change in y, over your change in x, which is your x2 minus x1. No surprises here. This is the slope formula. So your y2 we said was 4, minus your y1, which we said was 3, over your x2, which is, again, 3, and your, I'm sorry, 4, because this is 4 here, minus the x1, which is 3, and 4 minus 3 is 1, 4 minus 3 is 1, so your given interval is 1. So the slope over the interval given is 1. Now that's easy to see, where you've got, again, a difference in 1 with your x and a difference in 1 with your y. So let's take a look at this again, same kind of a problem, and excepting this time my x is going to, well, my x is going to stay at 3, but I'm going to change my y to 9. So let's see here. My x is going to be 3, so here's 3, and that's going to again be my x1. And now, but my second x is going to be 9. That's going to be my x2. And so I'll go up to my line here, and obviously where x is 3, y has also got to be 3. So that's going to be my, my y1. And then I'm going to do my dashed line from the x2 at 9, go all the way up to the line, and then over with my dashed line. And my y2 is also going to be 9. All right? So as the input x increases, from 3 to 9, the output which we call again g of x, increases from 9 minus 3, which equals 6. All right, so let's put that into math form. Change in y over change in x equals y2 minus y1, same thing, slope, over x2 minus x1. And that equals 9 minus 3. Those are the y2 and y1 coordinates, and 9 minus 3, x2 minus x coordinates. That equals 6 over 6. Oops, 6 over 6. And 6 divided by 6 equals 1. So again, the slope over the interval given and we'll say the interval of 6 given is 1. Okay? So that gives you how we find out the interval for the given slope. Now, let's move on to rate of change. So here we're going to find, and this is our last example, we're going to find the average rate of change of slope over the interval given. And just so you know, the IXL package will oftentimes ask you to write your answer in tenths, or they might ask for fractions or something like that. In this case, I'm just going to use this as a way that you might see this in tenths. All right, and then I'm going to show you this useful formula. This looks, again, very familiar. But notice what I did here. This is your y, because your outputs in function form are f of x. So I don't show y2 minus y1. Instead, I show f of x2 minus f of x1. x2 and x1, of course, are the x coordinates, but when they're put into function of x2, that means that's the output. Function of x1, that's output, and this the inputs. So here's a graph, and this is the function y equals x squared. So this is quadratic, and whenever you have a quadratic function, then you have your graph is going to be a parabola, not a line. All right, so we're going to write this function or this equation in function form. So that's going to be f of x equals x squared. This is going to be our x1. This is going to be our x2. Right? And so if I were to use x2 in here with this equation, my f of 6 would equal 6 squared, and my f of 0, so this is for x2, right? Although this is f of x2, which would make it the output. So don't think of it as anything more than the output. But the output for x2, and then the other output is f of 0, and that equals 0 squared. Okay, so f of 6 is 6 squared, which is 36. F of 0 is 0. All right. So again, rise over run. So the change in the rise over the change in the run is what we're using. And so that means we're going to, our y is, we're going to put our y in, the numerator. So that's going to be our f of 6. That's the y, the output. That output minus the other output of f of 0. Those are the two y's that we're going to get the change in. Over the inputs, x2 is 6 minus x1 is 0. And then, of course, this simplifies into 36 minus 0, because we said f of 6 is 36, f of 0 is 0, over the inputs of 6 minus 0. And that, of course, equals 36 over 6, which equals 6. So, to the nearest tenth, the average rate of change is 6. Now, that we know, that's clear, but remember you got a parabola here. So I want to pull out one other important point with this. And that is that our input x, if you remember, our inputs are always positive and negative. We actually have two x's, if you will. So there's this x over here. We'll call this x and this x, because they're both x's. This is our first one, so we'll call this x sub a and this x sub b. But positive and negative 6. So I've got a point up here, and I got a point over here. And of course, using the difference here, this interval is 6 units, but this interval up here, let's just put the dashed line here so you can see it. The interval from 0 to 6 is 6 units, but the interval from, if I can get this right, let's see here. So the interval, and this is 2, 4, 6, so this is 36. That's 36 units. Okay? So that's 36 over 6, the y over the x. All right? So again, it's important to understand, though, that you not only do you have this over here, you've got it over here. So if I took negative 6, I'm sorry, 36 over negative 6, I got a negative slope going over here, and then over here I've got a positive slope. And this is, of course, the beauty of parabolas and quadratic equations. All right? The important thing you want to remember is what we're looking for here is the average rate of change. And it is 6 no matter whether or not you're talking the positive or negative. But I wanted you to see the fact that this is going on here. Okay? All right, so I'm going to leave you to this. You've got everything you need for today, and have a great day. Talk to you later.